So the Pauli exclusion principle states that there can be no more than two electrons in each orbital. That's due to the fact that electrons can have two different spins, either a positive spin, a positive half spin, or a negative half spin. And essentially, what this states is, for example, essentially there can only be a maximum of two electrons in one orbital. And then that moves us on to the off-ball principle, which states that the orbitals at lower levels, at lower energy levels, are filled first. For example, we'll just draw an orbital diagram right now. So this here. So let me just get this here, and then 2. Okay, so that's 1s, 2s, and then we have 2p, and let's say 3s, which would be here. So what this states is that, for example, so this is the Pauli exclusion principle, basically saying there can be a maximum of 2 electrons per orbital, and let's say we have enough electrons to fill all of these orbital diagrams here. So then if we have 7 electrons, if this atom has 7 electrons, then based on Paul's principle of degenerate orbitals, stating that an orbital at the same sublevel will fill up all the orbitals at the same 1 electron per orbital. So this is going to happen if we have 7 electrons. So and this happens because it. Let me just quote here. So they all have the same energy levels, so that there's less mutual repulsion between the electrons. And so if we have an extra electron added to the atom, then the first one is going to be filled. The first p orbital is going to be filled. Then we have an extra one. Then the next orbital is going to be filled with an electron, and finally the last one. However, if we don't have these, then each one is going to be filled with a parallel electron, basically meaning they have that 3 electrons have the same spin at the same orbital.